Okay, guys, so for today's topic, what we're gonna see is the parabola. So let me begin with the title right here, parabola. So as you have seen the parabola, and if you recall, the parabola will be a U-shaped curve, something like this. Okay, that if we position that curve exactly at the origin of the coordinate plane, or the vertex of that curve at the origin of the coordinate plane, you will have an equation that resembles to one y equals x squared, right? You should remember this because this curve that has its vertex at the 0, 0 coordinates is a parent function of the parabola, okay? When we move this curve outside the origin, let's say that I'm drawing here the coordinate plane, and now we will move this parabola outside the origin. Our vertex will have coordinates with other numbers. And if you recall, we call those numbers h, k. So in general terms, the vertex will always have coordinates h, k, where h is the x coordinate. H is the x coordinate and k is a y coordinate, okay? So given this, the way on which the equation will be modified, if you recall, when you're translating parabolas, your equation will be y equals x minus h squared, where the h is actually the x coordinate that you will move your parabola horizontally, plus k. And k will be the y coordinate that will tell you how many units to move your parabola vertically, right? This is probably something that you should remember that we saw since the beginning of the course, and actually that you saw since last semester, okay? So given this, let me just rearrange this last equation. Let us say that we're gonna subtract the k on the other side of the equation, and you will get y minus k equals x minus h squared. Okay? I think this makes sense to you. I just subtracted the k on both sides of the equation, and I remained with the minus k on the left side, okay? And beyond this, I'm gonna add a coefficient right here, a coefficient that we're gonna call it, and sorry for the writing, I don't know what's happening. We're gonna call it letter A. Remember that any coefficient, this is a coefficient. Any coefficient that is besides the parenthesis that is squared, what we'll do is to scale your parabola. You could scale it making either taller or making your parabola wider, okay? But that's the effect of that coefficient, okay? Now, I will deduct another equation from that rationale that we just made here, where you will have y minus k equals 4 times p times x minus h squared. Okay? This 4 times p is the coefficient. The only thing that changes here is that you've got a 4 and a p, and I will tell you now just in a few moments, what does P mean, okay? Now, let us put the notes there so you can take pictures or you can write down, okay? And in the meanwhile, let me draw another parabola with the coordinate plane. And let me draw it something like this, where you will have your vertex at the very bottom with coordinates h, k. And let me introduce you to other topics or two new concepts here, sorry. The new concepts are, we'll have a point inside the parabola and a line outside of it, okay? We call this point that is inside the parabola the focus. The focus. And this line that is outside the parabola, the directrix. Directrix. Okay. So why does a line and why does a point appear now in the definition of a parabola? Well, geometrically, as you recall, we saw previously that circles are curves where any point on that curve will have exactly the same distance to a fixed point that we call the center. The center is a point at the middle of the circle, right? So that's a geometric definition. Geometric definition of the circle. The parabola will also have a geometric definition. If I grab any point on it and I measure the distance, let's say this is point P, and I measure the distance from that point P to the focus, and then I measure the distance from that point to the directrix. These two distances, the distance from the point to the focus, will be the same as the distance from the point to the directrix, okay? Even though these two distances do not look equally scaled in this drawing, mathematically and geometrically, they should be equal, okay? In any point within the parabola, okay? Great. So the parabola is a curve that you can draw by finding the distance from the point on the parabola to the focus and the distance from the point to the directrix, and both distances should be equal, okay? That's a geometric definition. Now, there is a very special distance in the parabola. That is the distance going from the vertex to the focus and from the vertex to the directrix, both of them. And this distance, we call it P. Okay? That is a P that appears in the equation of a parabola. Let me do a stop here. so you can copy and process information. Okay, you can stop the video, but we will continue, okay? Now, for any problem that you will solve about the parabola, you will have to remember that you've got positive parabolas, and negative as well. Okay, there are horizontal parabolas, horizontal, and vertical as well. Okay, so for any problem that you will solve on parabolas, you will have to gather the table that we will construct right now. Okay, sorry for that. So let us draw a table where we can identify the horizontal and vertical parabolas, positive and negative. Let's begin with a vertical positive. And let us draw the axis, the coordinate plane. Let's draw in black a parabola right here. Let's find the vertex. Your vertex always will have coordinates h, k, okay? As we have seen in the previous parabolas, you will have a focus and you will have a directrix. Okay? The focus is a point that will be always inside the parabola, always inside the parabola. And the directrix will be always outside the parabola, okay? Now, what you will have to remember is that the distance between the vertex and the focus is P. P could be 1, 2, 3, 1/4, 1/5, 1/2, whatever number, okay? And it will be always positive. If I draw a point and I position this point on the vertex, okay? And now I want to find the coordinates of the focus. What I would do is to move this blue point vertically to the focus, right? How many units do I move the point from the vertex to the focus? I move it P units, right? Do I move it horizontally? No, I do not move it horizontally, only vertically, okay? So what does that mean? That the x coordinate of the focus will remain the same as the x coordinate of the vertex. The x coordinate of the focus will be h. Now, what will be the y coordinate of the focus? K plus the distance p. The distance p is the distance that I move vertically to the top from the vertex, okay? Now, if I want to get the equation of the directrix, you should notice that the directrix is a horizontal line, right? If it is a horizontal line, the horizontal line crosses the y-axis. Do you agree with me? If it crosses the y-axis, the equation of the directrix, sorry, will be y equals something. What is that something? Again, if I draw a point that goes from the vertex to the directrix, I will move P units to the bottom. Okay. If I move vertically, I will grab my K. And if I move to the bottom, I will subtract P units, K minus P. And those are the coordinates of the focus and the equation of the directrix. Finally, what you have to remember here, guys, is that parabolas have also an axis of symmetry. There is a line that crosses in the middle of the parabola and that actually crosses through or passes through, sorry, the vertex and the focus. The axis of symmetry will have the equation x, because it crosses the x-axis, equals h, because has the same x coordinate as the focus and the vertex. I hope this helps to identify vertical positive parabolas and all its elements. The same will happen with the other types, okay? So let us draw now. Oh, sorry, before that. As you recall from the previous example, we've got the equation of a vertical positive parabola, right? As y minus k equals 4p times x minus h squared, right? So the equation of this parabola will be y minus k equals 4 times p x minus h squared. Great. Let us look at vertical negative one. Coordinate plane. Now let's draw a parabola that will be vertical and negative, and your vertex will be at the top, right? You already know that the coordinates of the vertex will be h comma k. The focus will be always inside, so the focus will be right here. And the directrix will be on the other side, and in this case will be a horizontal line. Okay. Just as with the previous example, we have to identify the p-value. The p distance is between the vertex and directrix and vertex and focus, okay? So, if I move downwards from the vertex, the coordinates will be h comma k minus p. If I move to the top from the vertex, then the equation of the directrix will be y equals k plus p. And if I want to know the equation of the axis of symmetry, the line crossing the vertex and the focus, well, the axis of symmetry will have the equation x equals h. What can you tell from both parabolas? Well, very simple. On the first one, your focus will have y coordinate k plus p, and on the second one, this coordinate inverts the value of p, right? The same happens with the directrix. And how do I get the equation of this parabola? Well, if the first one had this form of the equation, the vertical negative will have exactly the same equation, but now will be negative. So you will have y minus k equals minus 4p times x minus h squared. Great. Let's stop it here for a little bit. Okay, let's continue. Now let's see the case of a horizontal positive. Let's draw again the coordinate plane. And now a horizontal positive parabola will look like this, right? The vertex is right here. Again, h comma k coordinates. H comma k. And now the focus will be inside the parabola to the right. The directrix to the left, right? Okay, that looks weird. There we go. Okay. Now, our p distance or p value will be from vertex to focus and from vertex to directrix. Now the p distance moves horizontally. So the coordinate that I'm gonna affect is the x coordinate. My focus will have coordinates h plus p, comma k. In this case, again, if I were to draw a point that goes from the vertex to the focus, the point moves horizontally, right? And it moves p units to the right. It doesn't move vertically. So what that means is that the y coordinate remains the same. And the only one that I affect is the x coordinate. So you will have h plus p as an x coordinate of the focus. What happens with the directrix? Now the directrix is a vertical line that crosses the x-axis, right? So the equation will be x equals h minus p. The contrary to the x coordinate of the focus. And sorry for this, let me move these letters up. And if you want to get the equation of the axis of symmetry, well, the axis of symmetry is a horizontal line that crosses the y-axis and will be equal to k. The same as with the vertex and the focus. Great. Now I need the equation of this horizontal positive. If the vertical begins with y, now the horizontal will begin with x. So I just need to flip the variables. X minus h equals 4p times y minus k squared. We're done with the equation. And now, the horizontal negative will be very simple for you. I'm pretty sure of that. So let's draw again the coordinate plane. Now a negative horizontal parabola will look like this with its vertex at h comma k. The focus will be inside to the left. The directrix will be outside and will be a vertical line. And now the p distance will be horizontal from vertex to focus and from vertex to directrix. Given this, the focus will have coordinates h minus p comma k, the directrix will have the equation x equals h plus p, and the axis of symmetry, sorry, will have the equation y equals k. And if you recall, we will need the standard form of the equation. So copying this one will be x minus h equals minus, because it is negative, for p times y minus k squared. And this complete table is the one that you will use for all your exercises in the platform. All the exercises about parabolas are solved looking at all times to this table. I hope this helps everyone and the concepts are clear for you. Okay, see you next time. Thank you.